Lesson: Techniques to identify bias. Addressing bias in artificial intelligence systems is a critical component of ensuring ethical governance and fairness. Techniques to identify bias are indispensable tools for professionals aiming to create responsible AI systems. A comprehensive understanding of these techniques not only helps in identifying the presence of bias, but also in crafting solutions to mitigate its effects, thereby enhancing the fairness of AI systems. One fundamental technique to identify bias is data auditing. Data auditing involves a thorough examination of the dataset used to train AI models. This process requires scrutinizing the dataset for any imbalances that may skew the system's outcomes. For instance, if a facial recognition system is primarily trained on images of lighter-skinned individuals, it may yield inaccurate results for darker-skinned individuals. A practical tool for data auditing is the open-source library Fairness Indicators, which provides visualizations to assess the fairness of machine learning models. By using such tools, practitioners can pinpoint specific areas where data may be inadvertently introducing bias. Another technique is to employ fairness metrics, which offer quantitative measures of bias in AI systems. Fairness metrics help in assessing whether different groups receive favorable or unfavorable outcomes from a model. One common metric is disparate impact, which evaluates whether a particular group is adversely affected by a decision-making process compared to other groups. By applying fairness metrics, professionals can monitor and quantify the extent of bias, enabling a more objective analysis of AI systems. Algorithmic auditing is another critical technique. It involves a systematic review of the algorithms themselves, assessing how they process data and make decisions. This can reveal biases embedded in the model's logic. For example, analyzing the decision trees of a model can expose if certain nodes disproportionately affect specific demographic groups. Tools like AI Fairness 360, developed by IBM, provide a suite of algorithms to test and mitigate bias, allowing for a more transparent examination of AI models. Incorporating diverse perspectives is also a significant method for identifying bias. Engaging stakeholders from different backgrounds in the development process can reveal biases that might not be evident to a homogeneous team. This diversity of thought can be facilitated through structured workshops and feedback sessions, ensuring that the AI system is evaluated through multiple lenses. Such an approach was effectively employed in the design of the Compass algorithm, which, although initially criticized for bias against African Americans, underwent extensive review and improvement through stakeholder engagement. Another actionable technique is to conduct bias stress testing. Similar to software stress testing, this involves subjecting AI models to various scenarios to observe how they perform under different conditions. This can help identify situations where the model's decisions deviate from expected fairness standards. Stress testing can be particularly useful in identifying subtle biases that might not emerge during regular testing. For example, a recruitment AI might show no apparent bias during standard operation, but could demonstrate bias when a candidate's name suggests a particular ethnic background. Additionally, employing ethical frameworks in the design and evaluation of AI systems can provide a structured approach to identifying bias. Frameworks such as the European Commission's Ethics Guidelines for Trustworthy AI offer principles that guide the assessment of AI systems for bias and fairness. By aligning AI development with these ethical principles, professionals can ensure a more comprehensive evaluation of potential biases. Case studies provide valuable insights into the application of these techniques. For example, the use of fairness metrics and algorithmic auditing in the improvement of Microsoft's Tay chatbot, which was initially biased due to its learning from user interactions, demonstrates the effectiveness of these techniques in real-world scenarios. By systematically auditing the interactions and applying fairness metrics, the team was able to adjust the learning algorithms to better filter out biased data inputs. Statistics play a crucial role in these techniques. For instance, a study by Buolamwini and Gebru found that commercial AI systems had error rates as high as 34.7% for darker-skinned women compared to 0.8% for lighter-skinned men, highlighting the critical need for bias identification and mitigation techniques. Such statistics underscore the persistent presence of bias in AI systems and the importance of employing robust identification techniques. In conclusion, identifying bias in AI systems requires a multifaceted approach that combines data auditing, fairness metrics, algorithmic auditing, stakeholder engagement, stress testing, and adherence to ethical frameworks. By leveraging tools like fairness indicators and AI Fairness 360, professionals can gain actionable insights into the biases present in their AI systems. The integration of diverse perspectives and extensive testing further enhances the ability to uncover and address biases, leading to more equitable outcomes. Through these techniques, AI practitioners can create systems that not only meet technical requirements, but also adhere to ethical standards, fostering trust and fairness in AI applications.